Everyone. So this is day 2 of expanding and condensing logs. The notes are rather short, so I thought I'd start off by going over some questions that you may or may not have, kind of highlight some things that we had talked about. So this was last night's homework. I recall going over this question last year, so I thought I'd go through it. You are expanding log base 2 of the square root of a minus 1 over 9. Because of the division, we are subtracting the numerator and denominator. So we would write this as log base 2. Remember when you square root, you want to write that back into an exponent. So that's a minus 1 to the 1/2 minus log base 2 of 9. Okay. From here, we can bring down our exponent. So by rewriting it like this allows us to bring our exponent down. So this would be 1/2 log base 2 of a minus 1 minus. Anytime that something can be rewritten, we want to make sure that we rewrite it. So 9 is the same thing as 3 squared, which if the exponent is 2, just like the 1/2, it comes down in front. So now this would be 2 log base 2 of 3. And that would be our answer. Okay? If you look at number 5, number 5 kind of brings up order of operations type of problem. If this is being squared, you cannot bring this out in front because the only thing that is being squared is the z minus 1, not the z as well. Okay, so we actually have to separate those first. If the whole thing was being squared like that, then we would pull that 2 out front. Okay, so what we have to do first is separate the z and this. That's multiplication, so we break them up with addition. So you'd say the natural log of z plus the natural log of z minus 1 squared. And now I can bring this 2 out in front here. So this would be the natural log of z plus 2 natural log of z minus 1. Okay? Something like number 9. Let's see. Number 9, we have the division here. We also have multiplication between those two. So when we break this up, it's going to be the log base 5 of x squared minus, but I have to put this in parentheses. I'm subtracting the whole denominator. And notice that I'm multiplying here, so when I break those up, it's going to be log base 5 of y squared plus log base 5 of z to the third. I need to distribute this to both of those. I'm going to bring the exponent down in front as well. So this becomes 2 log base 5 of x minus, and I'm going to bring that 2 down as well. So that becomes minus 2 log base 5 of y. I'm going to bring this 3 down, and I'm distributing that negative as well. So it becomes minus 3 log base 5 of z. Okay, we're going to talk about a problem where we are actually condensing with this subtraction. Anytime that you have everything that you start with and then you're subtracting, it all becomes in the denominator except for the very first part is your numerator. So notice this is your numerator, and then we're subtracting, which is why both of those are in my denominator. Okay, so to kind of illustrate that, we'll look at number 17. Notice I'm taking this, and I'm subtracting, which means then that this, and this all end up in my denominator as a product. Okay, just like here. These ended up in my denominator as a product, and if we look at the answer, they're being subtracted here and here. Okay, so when we rewrite this, I'm going to actually pull these numbers up top first. So I'm going to say the natural log of 4 minus the natural log of x, those stay the same, but minus the natural log of y to the 4th, minus the natural log of z to the 3rd, okay? And again, because of that subtraction, that's all division. So the very first thing that I want to recognize is this right here. That subtraction means that I'm going to say the natural log, they're all natural log, of 4 over x. But then because I'm subtracting the natural log of y minus 4, and then subtracting natural log of z to the third, it becomes x here, and then y to the fourth, z to the third. Okay. I think there's other problems. Let's see. Something like number 19. So you would do something like number 19 without a calculator. So let's say I simplify this. I would make this log base 2 of 16 times 81. Well, without a calculator, 16 times 81 becomes a really big number. And then rewriting that, I'd have 2 to the something power equals that really big number, which without a calculator is tough. But remember, using our rules of expanding, I can say that that's the same as log base 2 of 16 plus, because of the times, plus log base 2 of 81. Okay, so now if I go to solve this part right here, I can say I'm evaluating is 2 to the something power equals 16, which I know is, let's see, 2 times 2 is 4, is 4. So I know that log base 2 of 16 is 4. And then I try to evaluate this, and I'm going to say 2 to the what power is 81. Well, anytime I do 2 to a power, I'm going to get something that's an even number. So 81 is not going to help. So I don't know what this is. So I'm just going to write don't know. And if this is without a calculator, which this is, and I don't know, then I can't do anything with it. So then I actually just want to, I want to simplify my log. So that means I'm going to say plus, and I'm going to go back to what this was written as up here, because if it's log base 2 of 3 to the 4th power, then that 4 comes out in front, and it would be 4 log base 2 of 3. And then this would be my simplified answer. All right, last one that I'll do. If you look at, let's see, you look at something like number 27. Looks kind of difficult, but natural log of e, remember, natural log of e is saying, because this is base e that's not there, it's saying e to the what power is e, which is just 1. So anytime you see natural log of e, it's 1, which means that this is, so that means that this is natural log, and then if that's 1, it's actually a 6. Okay, let me give you a little bit better. This is saying 2 times 6 minus, and the natural log again is 1. It's not 1 to the 5th power, though. So this would be 5. So this would be 12 minus 5 is 7. So let me give you a little bit better explanation than that. If I were to rewrite this, this part right here would be saying e to the what power is e to the 6th. And you can see then your answer is 6, which is why that's 2 times 6 right there. And then natural log of e to the 5th would be saying e to the what power equals e to the 5th. And you can see your answer is 5, which is why that right there is 5. Okay, so it's not saying 1 to the 5th power. Okay, so let's go on to the notes. Sorry, here's your agenda. So there's some homework questions that we went through. We'll go through our notes right now, which are pretty short, and then you will start in your quiz review with any time that you have left. Okay. So just as a review, the product property, the quotient property, and the power property. So if you see that m and n are being multiplied by each other, it means that you will be adding your logs together. Okay, so it means that you will be saying that this is log base b of m plus log base b of n. Those are equivalent expressions. Okay, if you see something with a quotient, that means that you are subtracting. So that means now we're going to subtract m and n. So we will say log base b of m minus log base b of n. Okay, very similar to one another. This was multiplication, so we're adding. This is division, so we're subtracting. And then with the power product, we multiply. Okay, so if we see log base b of m to the n, then that means that we can bring this n down, and now we're saying n times, you don't have to put the time symbol, times log base b of n. Okay, so let's go apply these. Everything in this is what you guys did yesterday in your notes and your homework, so feel free to pause anything, try it, and then check your answer. If you get stuck, then obviously watch. Okay? Something like this we see as multiplication. So this is 5 times the cube root of x. So that means that we're going to add. So we're going to be adding here. Okay? So expanding means we want to make bigger. So this becomes log of 5 plus log, and I'm going to rewrite the cube root of x is x to the 1/3. Okay, anytime you have an exponent, you have to pull it down. So this is log of 5 plus 1/3 log of x. Okay, and then this is your answer. That is expanded. Okay, so let's try again. Notice the whole thing, 7 divided by x, is being squared. So the first thing we have to do is we have to pull that down. You could distribute the 2 to the 7 and the 2 to the x, but then you'd end up pulling that out as well. Either or will give you the same answer. So I always like to pull it out in front first. So this would be 2 log. And then I'm going to just rewrite the 7 divided by x. Okay, since that's division, it means I'm going to be subtracting. First I had to multiply. So the first thing I did was brought the 2 out, which is multiplying. Now I'm subtracting. Remember that this is 2, and then when I expand, this is log of 7 minus log of x. So you have to remember that you need to distribute this 2 to both of those. So this would be 2 log of 7 minus 2 log of x. Okay. You guys might be noticing some shortcuts that you can take as you start to see patterns. That's great. Just be careful that you aren't skipping too many steps and making mistakes. Okay? Okay. There are 3 things going on in this problem. We have a 5 times x squared times square root of y. Since all of that's multiplication, that means I'm going to break this up into 3 logs, all adding. Okay? I am going to bring down any exponents down in front as well. So this would be log base 3 of 5 plus, since this is x squared, I'm going to bring the 2 out in front, which means it's 2 log base 3 of x. Don't forget your bases. And then the square root of y, remember, is y to the 1/2. So that means this is going to be 1/2 log base 3 of y. So I did all that in one step. You by no means need to. You could have just rewritten, so I'll write that real quick. You could have just said log base 3 of 5 plus log base 3 of x squared plus log base 3 of y to the 1/2. And then you could have said, okay, I can see there's exponents. I'm going to bring them down, and that's what gives me this answer. Okay, anytime you have exponents and you expand, you have to bring them down in front as the coefficient. Okay, so now let's try some condensing problems. Okay, when I condense, I want to now go the opposite way, and I want to say, hey, I see subtraction here. So, and I see that I have log base 4 in both, so that means that I can combine those with division. So this was division. So since they're both log base 4, then I can say log base 4 of 9 divided by 15. Okay, so again, the idea when we condense is to say, well, this is redundant to say log base 4 and log base 4. Instead, I can say log base 4 and then of just the expression 9 divided by 15. Okay, simplify whenever possible. 9 divided by 15 can be simplified. If we divide by 3, it becomes 3 over 5. Okay, so then that is condensed. Anytime we're condensing, we should get it down to 1 log, or if possible, but most of the time you will be able to. Okay, I see the addition here, but I also see a coefficient, so I'm going to pull that up first, and I'm going to say log base 5 of x to the 7th plus log base 5 of 9. Okay, so the very first thing I did was pull that exponent up, which is your product rule. Now I can say, hey, well, I see that I have log base 5 of two things that are being added together, which means now I want to combine those with multiplication. So instead of saying log base 5 twice, I'm just going to say log base 5, and I'm going to do the product of these two. But remember, when you do product, we always write numbers first as our coefficient. So we wouldn't say x to the 7th times 9. We would say 9x to the 7th. Okay, you do not need parentheses. I didn't put parentheses over here, but parentheses definitely help us see what we are taking the log of. So it would be a good thing to put in. Okay. All right, next one. I'm going to pull all of these up first. So all of these coefficients. So this becomes log of x to the 8th minus log of 4 squared minus log of x to the 4th. And then remember, when I raise it to the 3rd power, I'm taking this whole thing and raising it to the 3rd. You can see two things actually simplifying here. So I'm going to rewrite again. So I'm going to say log of x to the 8th minus log of 16 minus log, and then when I take a power and raise it to another one, I multiply. So x to the 12th. Okay. Now I need to use the subtraction, and I need to say that that subtraction can be rewritten or rewritten using division. Since they're all just log base 10, say 16 here. Since they're all log base 10, I can say log base 10. I don't need to write the 10. And I can combine all of those, so it's not as redundant to do log of something minus log of something minus log of something. Okay. When we combine these, same thing as the homework problem. If I'm doing this minus this minus this, anytime I'm subtracting after the beginning, it is all going to go into my denominator. So the x to the 8th would be my numerator, and then since I'm subtracting, I'm now in my denominator, which would be 16. And then this also goes in my denominator as x to the 12th. So then those two are the product of each other. Okay, I'm not done yet. You can see that I have a little bit more simplifying to do. If I have x to the 8th and x to the 12th, my rules of exponents lets me subtract those numbers. So this would actually be log, and the difference of 8 and 12 is 4. So then in my numerator, I just have a 1 left, and then in the denominator, I'd have 16x to the 4th. And this would be my simplified answer. Okay, so it took a little bit of work to get there, but you can see that each time that you do one thing, you'll start to build and start to see that you can do one more thing until you get to the end. Okay, last question. Pam simplified the expression log of 9 plus log of 2 minus log of 3 to the expression log of 14. Okay, we want to know, how did Pam get this, and is she correct? So before we answer the question of is she correct, how she got it doesn't really matter which one comes first or which one comes second. I'm just going to do it in the order it was written. But how she got this is actually really important, because you want to make sure that if she was right, that you can get that answer, and if she was wrong, you understand why she was wrong so that you don't make that mistake. Okay, so pausing it right now and trying to figure out maybe how she came up with log of 14 would be a really good idea, because again, knowing where a mistake is very beneficial to making sure that you actually truly understand the rules of what you can and cannot do. Okay, so all right, assuming that you've paused this and now you have attempted it, hopefully you came up with a solution. I'm going to figure out how Pam got this. So the first thing I'm going to do is notice that Pam started with 3 logs and her answer just had 1 log, so she must have been doing some type of condensing, okay, which is what I would do too in this problem. So if I condense, I'm going to do some rewriting first. We have log of 9 plus, I'm going to bring the 3 up top here, so it's plus log of 2 to the 3rd plus, minus, log of 2 to the 3rd minus log of 3. Okay, I'm going to rewrite one more time. So log of 9 plus log of 2 to the 3rd is 8 minus log of 3. Okay, and if you notice, all of these are logs. So if we're looking at this in terms as terms, we could think that these are like terms, and we could say, well, if I'm doing log and log and log, well, then they're like terms. So 9 plus 8 minus 3. Well, 9 plus 8 is 17, minus 3 is 14. So then my simplified answer would be log of 14. So that would be how Pam got log of 14. So then that answers the first part. The second part is she correct? Well, let's say that we did some evaluating. Okay, so I agree with everything that she did first. Okay, I agree with everything she did second. So I'm actually going to pick it up right here where we have log of 9 plus log of 8 minus log of 3. Okay, so let's say that we continue to condense that, right? Pam kind of stopped right here, like she was good here, but then all of a sudden she just did 9 plus 8 minus 3 is 14. But based off of what we talked about yesterday and now today, we can continue to condense that, okay? If we're doing log plus log minus, we can say, well, this part right here is multiplication, so that would be log of 9 times 8 minus log of 3. And now if I'm doing this log minus this log, now that's division. So that would be log of 9 times 8 divided by 3. Okay, so again, this part right here was addition, which is why it became multiplication. This part right here is subtracting 2 logs, which is now why it became division. So now if we look at that, we can see that we have something that we can actually simplify. So I can simplify this in one of two ways, depending on how your mind thinks. One way is to do 9 times 8, which is 72 divided by 3. And 72 divided by 3 is log of 24. Or, if I don't want to make as big of numbers, I can say this part right here is 9 divided by 3. Well, 9 divided by 3 is 3, so then that is log of 3 times 8, which still gets me back to log of 24. This is your correct answer. Okay, so very important the point of this problem was to obviously get the correct answer, but to understand that you cannot go from here to here. This is not okay. You can't just get rid of the logs and then do 9 plus 8 minus 3 is 14 and then stick the 14 back into the log. Okay, you have to follow your rules of condensing logs. Okay, adding means that it's multiplying, subtraction means that it's division. You can't lose your log. Okay? So that takes us into our quiz review. Remember, the quiz is going to be on Tuesday. Okay, so you have the quiz review to work on over the weekend. Monday we will have a lesson on using everything that we just did in order to solve bigger, more complicated equations. And then Tuesday you will quiz. All right, on your quiz you will notice that you are graphing. So graph f of x and the inverse. Just graph your log, graph the function, and then use those coordinates. We've been doing that the last couple of days. You will see here that you're doing some inverses, state of domain restriction if necessary, convert to logarithmic form, convert to exponential form, expand, that's what we just talked about, condense, what we just talked about, evaluate, we've been talking a lot about, solving. Okay, so you're using your evaluation techniques to solve. You may be using some expanding and condensing, very simply. These I asked you to evaluate with a calculator, okay, so they don't work out as nicely. And then these I've asked you to solve, and I said a calculator is okay. Just because I'm telling you that you can use a calculator doesn't mean that you necessarily have to. It just means that maybe the numbers are a little bit bigger and, you know. Okay. Oh, and this one, oops, sorry. And this one you're going to have to add in this. I totally forgot to add in a percentage here. So you're going to talk about investing weekly, compounding quarterly, compounding continuously, but you have to know a rate. So it'd be at 7.29%. Okay, the answer key is online. I hope you guys have a good rest of your weekend. Please get started on your quiz review. Get as much done as possible over the weekend so you're not cramming on Monday night. All right, thank you.